Max Planck's initial formulation of quantum theory in 1900 and Albert Einstein's special theory of relativity in 1905 ignited a virtual firestorm in the development of new theories and applications. Einstein's theory of relativity explains how motion through space affects time and how mass is related to energy. Consider this yo-yo for a second. If I hold this yo-yo in front of you and then swing it back and forth, you would have no problem measuring the period of oscillation. Now, if I were to speed past you at a speed close to that of light, you would view the period of oscillation as increasing. Now, if I were to hold this yo-yo lengthwise and again move past you at a speed close to that of light, you would view the length of this yo-yo as decreasing. Well, as bizarre as that sounds, it says nothing about how much energy, just by being a yo-yo, this object has. All right, now for the cool stuff. Okay, behind this screen right here, I have a clock. Here's the back of it. Okay, so it's a good size clock. In a minute, I'm going to lift this blind, and I want you to read the time on the clock. Okay, you ready? Here we go. Did you get that? All right. Well, hopefully you saw the time as 2 o'clock. Fantastic. Okay, well, what just happened was the information in just the brief amount of time that you saw it was 2 o'clock. So this information, this light reflected off of the clock and came zooming at you, and you interpret it then as 2 o'clock. All right, so that's what just happened. Now, let's say that if the time was coming at you, if I play you for a moment, if the time's coming at you, hit you square in the face, and so you interpret it as 2 o'clock, what happens if you sidestep at the last moment and that information goes right by you instead of hitting you? Okay? You would perceive that you never saw the clock. All right? So you step aside and there goes the information. All right? Well, let's take Army Guy. Remember Army Guy? Let's take Army Guy and put him way down there. Way down there. Way down there. There. Okay? So as you sidestep this information, it zooms by you and travels all the way to Army Guy. Okay, well, here's the deal. You get the information right in the face. Okay, fine, no problem. The information, when you sidestep it, passes you and takes time to get down to Army Guy. Well, you and Army Guy both receive the information that it's 2 o'clock, but you receive that information at 2 different times. Okay, well, let's change things up a pace. You ready to go back to imagination time? All right, kick in the inner child here because it's time to break out the old spaceship. So here's our spaceship. Okay, here's our spaceship. Now, I'm going to come around and I have to get in my spaceship, right? Okay, so I'm going to hop in the spaceship. Excellent. Cool. Just like old days, huh? All right, now, I'm going to be in my spaceship, and let's say then that I'm able to travel at the same speed that the information is traveling. So, if this were the case, then I would be able to keep up with the time. Now, I'm going along in my spaceship, same as we're headed for Army Guy to deliver the information. I'm seeing this time, and I'm looking at it, and I'm saying, hey, it's 2 o'clock. It's always 2 o'clock. It's still 2 o'clock. It's as if, for me, time has stopped. Now, another way to think of time stopping might be to say the second hand takes an infinitely long time to go through one click. Okay, or one tick rather, because clocks tick rather than click. Well, anyway, so we're zooming along at 2 o'clock, and the time isn't changing. For me, time has stopped. All right, well, I'm going to slow down just a little bit. Okay, I'm slowed down just enough that this information goes past me, and for me now, time is now starting to tick again. But it's as if these tickings take an awfully long time. So in essence, as I go the speed of light, for me, time stops. If I were going just below the speed of light, time has been stretched. It takes an extra long time for that tick to occur. We call this phenomenon time dilation.